So here are some different types of errors. There's random error, which, this is just error by chance, purely by chance. And then there's systematic errors. So, random errors are mainly due to uncertainties in the measurement process. For example, they can be caused by the accuracy of measuring instruments, such as thermometers, or by fluctuations in measurement conditions, can be temperature, humidity, or time. The natural physiological fluctuations in human subjects are also a source of random error. So in order to manage this, large sample sizes can be used to average out the effects of individual measurement errors, and statistical methods can be used to quantify the error range. For example, by taking multiple blood pressure measurements and using the average of these measurements, the effect of random error from a single measurement can be reduced. So that's one way to reduce the random error. Random errors, these are errors that occur randomly for each measurement, and they're characterized by different results after repeated measurements. So again, it could be accuracy of your instruments or just environmental fluctuations, and you can overcome this by having large sample sizes or do multiple blood pressure measurements at different times to overcome that. Another type of error is systematic error. Now, systematic errors, this type of error can be caused by consistent biases in the study design, the measurement methods, or data collection processes. For example, it can be caused by sample selection that is biased towards a particular age group or gender, or by the use of uncalibrated measuring instruments. So to reduce this type of systematic error, it needs to be clarified. It needs to be carefully planned at the study design stage. For example, a double-blind experimental method can be employed to reduce the influence of the researcher or the subject bias. So randomization techniques can also be used to reduce the bias in sample selection. So that's one way to overcome this type of error. So, and one example of this is the scale always shows 2 kilograms less. So your accuracy, your precision might be high, but then your accuracy is off. So you'll be missing the target. And I can get into a whole nother lecture on accuracy and precision, which I think everybody should know about those terms. Measurement errors, these are errors caused by problems in the measuring process itself, such as inaccuracy of the measuring instruments or incorrect readings by the measurer. For example, the use of old or uncalibrated thermometers can result in values that differ from the actual temperature. So to reduce this, make sure you calibrate your instruments regularly. And you can use automated measuring instruments. It can help as well. In addition, for critical measured values, it is important to measure multiple times to check consistency. And next type of error I wanted to go over is sampling errors. Now, sampling errors are different. And this one requires special attention. This can be an error due to a sample drawn from a population not being representative of the population as a whole. For example, if the opinions of the population of an area are surveyed, but only from a particular geographical area or socioeconomic background, the results may not accurately reflect the opinions of the population as a whole. So you need to have methods to overcome this problem and to mitigate it. And you can mitigate this problem by using random sampling or increasing the sample size or using stratified sampling methods. For example, you can have individuals categorized into different age groups and make sure you sample enough individuals from each age group. So an example of sampling error, this can be opinions from a small questionnaire survey do not reflect the opinions of the population as a whole. There's also another bias. This results from a lot of survey or interview type questions in social sciences or medical sciences. And this is an error caused by respondents' subjectivity or just faulty memory during a survey or an interview. For example, research participants may incorrectly report on their lifestyle or health status. So to reduce this type of bias, it's very important to ask clear and concise questions. So you want to have a clear question design and also collect data from multiple sources if possible. And you can use objective data sources, for example, medical records. In addition, data validation and cross-validation can also help. For example, a patient may underestimate their own dietary habits and answer questions that make them look more favorable than their real experiences. There's also errors that can be related to missing data. So finally, we should consider these errors, missing data in your data set. Missing data can be caused by a refusal to complete a survey, errors in the data collection process, or just unavailability of information. For example, if a survey is missing answers to key questions, the data set may not accurately reflect the full picture. So one way to address this problem is to analyze the patterns of missing responses and apply appropriate data completion techniques. For example, the mean assignment and multiple assignment methods are often used. However, missing data should be handled with caution depending on the circumstance.